So hello everyone. This week is week 6. This week we're going to talk about another important topic, data communication and the networks. So this is one of the most important part in IT because we should understand how our computer are connected with each other and how our information is exchanged. So if you want to be a network engineer or cloud developer, even the IT support, so this part is very important. So today's lecture will be divided into 3 main parts. First is the data communication, some fundamental knowledge, and second is the communication computer networks. And last, I will talk about some internet technologies. So for this lecture, you are required to read the following chapters in your textbook. Also, if you have time or if you're interested, you are encouraged to read more relevant materials. So first, let's talk about some fundamental knowledge about the data communication. First, we should understand what is the simple data communication module. And this is the general block diagram to show you what are these key components in our communication system. So in the very beginning, we have the source, which is source of the data or source of the information, followed by the transmitter. So if we only have the source, that's not enough. We should have the transmitter to transmit our source to the network. So in the middle is our transmission system to help with to deliver the message to the far end. Then the information will be received by the receiver. So after receive the message, it will pass this information to our destination, which is another computer or some other devices. So here is an example of how a workstation communicates with a server. So in this case, our transmission system is our public telephone network. So our public telephone network is an analog system. So since our workstation and server, they are both digital. So the workstation cannot directly send the data to the public telephone network directly. So that's why we need a transmitter, which is the modem. So modem will change the digital signal from the workstation to analog. So then analog signal will be transmitted to another modem, which is connected to the server. So this modem from the server side will change back from analog signal back to the digital signal, which is the server constant. So finally, the information will arrive at server path. So that is a simple data communication module. So here's the explanation of each part, which we have introduced already. So what data communication? So transmission of the digital data between 2 or more computers. So how can we define the data communication? So the definition is quite simple. It is transmission of the digital data between 2 or more computers or other devices. There are 3 fundamental characteristics. First is delivery. System must carry data to the correct destination. So if you should bear in mind, we should always know what's the destination is the other identity, or either IP address or some other MAC address, or some other identity to show that we have delivered the package to the right person or right computer. Second is accuracy. System must deliver accurate data as per sending format. So accuracy, we can use another word, reliability. So we should deliver our information reliable. The last is the timeliness. So the system must deliver the data in time. So this we can also use another word, latency. So many applications cannot bear the so long latency. We call it the latency sensitive, especially for those control systems. So the latency should be within the package deadline. But some system may be more latency tolerant, such as video streaming. So if your video is delayed 1 or 2 seconds, you, you can still look at the video. You won't complain. But for those control system, the latency is very, very important. So there are 5 basic components of data communication, which is sender, receiver, messages, transmission media, and the protocol. So sender and receiver, they are very similar to the previous described source and destination. Messages is the information that sender wants to give to the receiver. So the format of the message could be in different formats, such as text, audio, video, pictures, so anything. And transmission media is the way we want to transmit this message. Could be through the cable, and we have different cables, or through the wireless method, or through Wi-Fi or Bluetooth. And protocols. So protocols is kind of like the rules we set to transmit our information. So I will go into the details about the protocols later. Then let's talk about data transmission. So for data transmission, first we need to know the 3 fundamental data transmission modes. First mode is called simplex mode. In this mode, data can be sent only in one direction. There are many examples in our daily life, such as monitor. So for the monitor, signal can be only sent from our computer to the monitor. So usually there's no way back. So no monitor will send any information to our computer. Same for the radio and the television broadcasting. So our radio set or the TV set, that's just a receiver. They never send anything back to the radio and the television station, but not for the modern radio and modern television. Now we have the online radio and online television, but that difference, because in this case, you can order your program online, so you can send something back to the server, so which is not the simplex mode. So only the traditional radio and the TV broadcasting, they are simplex mode. So same for the remote keyboard and remote mouse. The second mode is called a half duplex mode. It means that data can be transmitted in both directions on one single carrier, but not at the same time. The example will be the walkie-talkie machine. So this machine is usually used for the police station or some other like a mining industry. So 2 people, if they want to talk to each other with the walkie-talkie machine, if we want to talk to B, and he has to hold the button to speak. And so during this time, the other person cannot speak, then he has to listen. So when the first one finishes their talking, then the other one can talk. So there's no way that 2 people can talk to each other at the same time. So that's the half duplex mode. The last mode, which is also the most popular and widely used mode, is full duplex mode. In this mode, data can be sent in both directions simultaneously. In nowadays, most of our network system or communication system, they are full duplex mode. For example, our Ethernet, our mobile system. So two computers, they can transmit the data or information to each other at the same time, and it won't interfere with each other. So that's the 3 fundamental transmission modes. So in the beginning of the lecture, if you remember, I mentioned something about the analog signal and the digital signal. For the analog signal, what you only need to remember is that an analog signal is in a continuous form. So just like this figure, so that's the analog signal. So everywhere, our signal is continuously. So the good thing about analog transmission is that it's easy to build and it's not expensive. Because, for example, for our telephone, since our human voice is also continuous, so it will be very easy to change our voice signal to the analog signal without much big changes. So that is our the old style phone is like this. So after we have our computer invented, then comes with the digital transmission. Transmission of data using distinct on and off electrical states. So 0 and 1 are called bits, as we know before, right? So the combination of these bits can form the digital data. So you should always know that our computer can only understand 0 and 1. It means that the computer can only receive the digital signal, just like this. So if the sender wants to send something to the receiver, it has to send like 0 and 1, which is form a digital signal. So the encoder will change it to some other digital signal over our Ethernet, and then the decoder will change it back to the 0 and 1s, so the receiver can understand. However, our the current network is very complicated. We have several analog signal, digital signal, analog network, digital network. And what happens if we want to, for example, transmit some analog signal over the digital network? Then we should use some AD or DA converter. So here is an example. If we want to use the microphone to say something and use the speaker to broadcast it, so and we have to use our IP network or digital system to transmit the data. So how can we do? As we know that our voice is is an analog signal, so it's like this. So before we send to our digital system, we need to convert our analog signal to the digital signal. It's like this. So after the ADC, which is an analog to digital converter, our voice, which is analog, will be changed to the corresponding digital form, 0 and 1s. So this form can be sent through our digital system. So once our signal arrives at destination, which is the speaker side, but however, speaker is also an analog device, cannot receive any digital signal. Then we should use another DAC, digital to analog converter. So then this DAC will change back from the digital signal back to the analog. But due to the converter, two converters, so the signal has already been like interrupted. So we cannot like 100% to recover the whole analog signal. But still, you can see that the form is look like the same. It means that our voice will be changed a little bit, but it's okay. But we can still recognize who is speaking. It means that there's a tiny difference from the speaking here and from what we talk. So there will be some difference, but that's no big deal. So here is one example of the ADC or DAC. Actually, there are many examples in our daily life, so you can think about that. So the next concept for data transmission is the data transmission media. It means the pathway used to carry signal from sender to receiver. There are two basic transmission media types. First is called guided media. So data signals are guided along the path like cabling systems. So for cabling systems, actually we have many different types of cables. Here I just listed three the most commonly used cables. First is called the twisted pair. So the twisted pair cables is usually used in our Ethernet. So most of our Ethernet is based on this kind of cable. So the good thing about the twisted pair cable is usually very cheap. And also it's very flexible. So it's very easy to build. And also it's very easy to install. But also, we have the disadvantage of about this kind of cable. The major problem is the attenuation problem. So the signal transmitted in this kind of cable attenuated very fast. Usually the signal cannot be transmitted over 100 meters. So that's why you cannot see any listener cable which is longer than 100 meters. The other problem is that it is very prone to noise. So the second popular cable is called the coaxial cable. Coaxial cable is usually seen in our the television system. So from your TV to the wall, you use some cable to connect, right? So that is a coaxial cable. So this kind of cable is also very easy to install, and also it's not prone to noise due to the structure. So if you see this structure, the cable structure, you will see there's a metal protection around the cable. So this metal protection will filter out all these noises and to make the signal inside clean. But this cable also has several drawbacks. First is it has higher loss per unit distance than twisted pair. It means that the signal has more serious attenuation problem than the twisted pair. And the other problem is that it is a thicker cable to work with. So from this picture, you can see that this cable is much thicker than the twisted pair. So in some scenarios, this cable is not preferred. So the last, which is most popular cable, is called the optical fiber cable. So in Australia, for the MBA network, all the network is based on this optical fiber. And also the internet between different countries and different continents. So all the networks nowadays are based on this optical fiber. So why is like that? Because it has so many advantages. First is the great capacity. It means that this fiber cable can support huge data throughput. Since this fiber cable is not made from metal, usually it's made from some special plastic. So that's why it's very light. And also it has a very low attenuation problem. So this is not true from the very beginning. So when fiber is invented, it also has a very big attenuation problem. So after the people find a new material for the fiber, nowadays this problem has been solved. So now the signal through the fiber can be transmitted to thousand meters with a very little attenuation. So that's the very important advantage. Since also in fiber, the signal is not electrical, it is optical. So it is so the fiber cables is immune to the environmental noise. So that's also another very good advantage. Since the signal is optical, so it's very hard for any people to hijack our information from this cable. So it's very secure as well. But the drawback of the optical fiber is usually very expensive because it uses very special plastic to build this fiber. So it's kind of expensive. The other reason to be expensive because it requires some additional devices because the signal transmitted in fiber is optical. But however, our computer cannot understand the optical signal. So that's why we have to use this kind of electronical to optical or optical to electronical converter. And this converter is usually very expensive. So that's the two main problem about the optical fiber cable. So here I just mentioned the most popular used cables. Actually, there are many other more different cables, so you can just search for yourself. But I don't have time to mention all these different cables here. So the second type of the transmission media is unguided media. Means the data signal can flow through the air. This type of communication is often referred to as wireless communication. So wireless communication is also very important nowadays in our computer systems, such as our mobile phone 3G, 4G, 5G system, and our Wi-Fi, Bluetooth, Zigbee, and LoRa. They are all wireless. So even before the radio or the TV, we also use the wireless signal to receive programs. So as the radio, it has one important property of the radio is the frequency. So the below figure shows the part of the electromagnetic spectrum ranging from 3 kilohertz up to 900 terahertz used for wireless communication. So if the frequency is very low, like this, 3 kHz, is used for very special wireless communication, because if the frequency is very low, it means that this signal can be transmitted to a very far distance. So it's usually used for the military communication. And then when the frequency goes higher, then we can have our normal cell phone system up to 900 gigahertz. When the signal goes even higher, 2.4, it is our Wi-Fi signal, the frequency band. Then when it goes to very high, like 5 giga or 50 gigahertz, that is a microwave range. Then when it goes to even higher, like up to 400 terabytes, that's light wave. So even for the light wave, we have the light communication as well these days, but that's very special. So this will give you some hint about this wireless communication. So next is the data transmission speed. It is the amount of data transferred through a network over a given time. It is also called data transfer rate. So what is the difference or the relationship between the data transmission speed and the bandwidth? So the bandwidth means the capacity of a wired or wireless network communications link to transmit the maximum amount of data over a network in a given amount of time. So usually the broader the bandwidth it is, it means the faster of the data transmission speed. So here are two problems about the data transmission speed calculation. So you can spend some time to work on it. So I can guarantee that this kind of problem will definitely appear in your final exam. So as we know, the types of cables has a different properties in terms of supported bandwidth, supported communication distance, and the price. So this table gives you a summary about the differences between the different cables. So please bear in mind, and this is a very important table. So as per this table, you can choose the most appropriate cables in the different scenarios. So for the data transmission methods, we only have two main methods. First is called a synchronous transmission method. So in this method, we just send our information packet by packet. But when we send our packet continuously, and how can the computer distinguish different packets? Then comes with another important concept: start bits and stop bits. So here is an example. If we want to transmit 1 byte of data, which is 8 bits, first we can send our start bit 0 to indicate the beginning of the 1 packet, followed by 8 data bits, which is 1 byte. Then we can add 1 parity bit to check the correctness of this packet. And at the end, we can add the 1 stop bit, which is 1. So this is one complete package for the asynchronous communication method. So what is parity? Parity is a form of error checking. There are two ways to do the parity. First is the even parity. So even parity is the parity bit is added so that there is an even number of ones. So for the order parity, so the parity bit is added so that there's an odd number of ones. And here is example. So here is our the packet. So how can we calculate first the even parity? Then we calculate, okay, how many ones in this packet? In this case, we have 5 ones. Is that even? No. So in this case, we add 1 here. Then for the odd parity, so we have like 5 ones. Yes, it's all right. So then we have a 0 here. So if we have one package like a bit changed during the transmission, we can detect, okay, since for example this one is changed to 0, it means that if we do the parity checking, it should be we should have a even like a so here is the example of one package. If we want to do the even parity, we'll just calculate, okay, how many ones it is here. So since it's 5, not even number, then we put the 1 here. But if for all parity, so since it's 5 ones, then we should add a 0 here. Then how can we check the errors? So if we just change this one to 0, then this one will become 4 ones, which is then should be 0. But however, our checksum is 1. It means that there are some errors in this package. So same for the odd parity. So you can notice that this kind of method can only detect 1 bit error. So if we have like multiple bit errors, so we cannot detect the changes of the package. So that's the drawback. So then let's talk about the synchronous transmission method. In this method, there's a no start bit or stop bits, and the characters transmitted in continuous stream, which is much faster because we don't waste our bandwidth to transfer those useless start bit, stop bit, and parity bits. And different from the packets in the synchronous transmission method, there's a new concept called block. It is sent a large block of data in this mode, and each block has a special synchronization bytes we call sync bytes, which is sent at the beginning of each block, and this allows the speed of the receiver and the transmitting devices to be adjusted. So once synchronized by using these sync bytes, the clock are used to determine when bits are to be sent. So now you can see that the major difference between the asynchronous and synchronous method is the use of the clock. So if you think that system is used the clock to synchronize the 2 devices, then it's used synchronous. Otherwise, it is the asynchronous method. And each block also has some other information, such as the control information or the error correction information as well. And here is the example to send 1,000 bytes of data within just four sync bytes and 2 control information bytes and the other 6 error correction bytes. So this is one example. So you can see that to send this 5,000 bytes, we only use some extra, totally 12 bytes over this 5,000, which is much more efficient than the asynchronous method. And here is the comparison between the synchronous and asynchronous method. So for the synchronous methods, it is very fast. So we can send a large block of data by using this method, but it had to use the clock for the device synchronization. And then it may have to wait until data to be sent. So that's the thing. So I have to wait until all that has been sent. For the asynchronous, it is slower because have to use some extra stop and start bits to control the package, but it is cheap and easy to implement because we don't require this additional clock. Actually, this clock is not easy to implement because uh, first you need to have two devices synchronized, and also different devices. The clock may have some tiny difference between the different hardware, so it's not easy to get two devices perfectly synchronized. And another thing about the asynchronous method is can send the data when it's ready. So we don't have to wait until data to be sent. You just send anytime you want. So that's the difference between these two methods. And then we should understand how can we calculate the efficiency for these two methods. So the transmission efficiency, it is defined like this. It's the number of the useful bits divided by the number of the total bits we send. So for the asynchronous transmission, so what is the efficiency when sending 1,000 bytes of data? When the packet has just one start bit, eight data bits, and one parent bit and two stop bits. So you can calculate by the definition. Same for the asynchronous transmission. So what is the efficiency if we want to send like also 1,000 bytes, but we only have like three sync byte, two control information byte, and five error correction byte. So what's the difference of this efficiency? So you can have this like calculation and compare difference. Then let's look at data communication hardware. Nowadays, there are many different types of data communication hardwares. I will go through the most popular hardwares in our daily life. First is the broadband modem. In Australia, many families are still using ADSL method to surfing the internet. So if you want to use the ADSL, you must have this ADSL modem at home. So this modem will help you to transfer your computer signal to the analog signal, which can be transferred to our telephone networks. And usually this ADSL modem has the built-in Wi-Fi, so you can also connect your mobile phone to this modem and to surf the internet. And then it's the wireless modem. So the wireless modem usually use mobile connections such as 3G, 4G, 5G. However, our desktop and laptops has no ability to directly connect to the mobile networks. Then you need this USB dongle. So once you insert this dongle to your desktop or laptop, then your computer has ability to surf the internet by using these devices. So the next hardware is called the wireless access point. And why we call it access points? Because for those wireless devices, such as our smartphones, tablets, even some wireless sensors and wireless actuators, they have no ability to directly connect to the internet. So they have to connect to the access point first. So this access point will help them further to connect to the internet. So that is the job of this wireless access points. Then it's the router. So router connects multiple devices or other routers together and transmit data to its correct network destination. It could be both a wired or wireless router. And there's another router called the mobile broadband wireless router. And this router was very popular in some like rural area in the region area, because in that area to install NBN fiber or even ADSL is too hard. But fortunately, they have the telecommunication coverage. So this router will connect to the existing telecom network. And then our computers can connect to this router for the internet service. So then it's the hubs and switches. So hubs and switches are often used in the local networks, which is LAN. So they are central points for network cables to connect devices or other networks. And typically, hubs can support a small size of networks, but switches can support a larger size of networks. So in some other lectures or subjects, you will learn that hubs is a kind of like a layer 1 devices, but switch is a layer 2 device. So although they are similar in functionality, but they have pros and cons. And also some switches, they support some simple routing protocols. So you can use some very advanced switch as a simple router. But to do the routing, you still need to use the professional routers, which is to route your packet more efficiently. Now let's move to the next topic, computer networks. So what is the definition of computer networks? It is a collection of computers and devices connected together via communications devices and the transmission media. And why should we use computer networks? And what are the reasons to use a network? Maybe this question to you is too simple because you use the network every day and you get used to it already. So you maybe never think about that before. So think about what happened before the computer networks appeared. So before that, we have to use some very inconvenient method to exchange data between different computers, such as by using floppy disks. And later, when the computer network was invented, people found that by connect the computers together, we can very efficiently to exchange information and the data. Of course, we can use the networks to do more things, such as we can share the hardware as well. So we don't have to install the hardware to each computers, or we can share our software even. And later, when the computer networks goes to the banking system, so we can easily transfer money from one place to another very efficiently. And there are many other reasons to use computer networks. Maybe you can think about that to see how important is the computer networks it is. Let's talk about networking fundamentals. About different types of networks. First type is called LAN, local area network. LAN has been widely used in different scenarios, such as in office, in schools, even in government, or at home. So LAN is usually used in a very limited area, so just in 1 or 2 rooms, or even in one building. So previously, LAN is connected with cables, Ethernet. So nowadays, LAN most times is based on the wireless network by using Wi-Fi. So the second type of network is called WAN, the wide area network. So compared with LAN, so WAN covers a large area. So it could be a city area or a state area or even a country area. And our internet is the biggest WAN. So now you know that what's the definition of WAN. And there are some other types of networks. First is called a MAN. So it's a metro area network. So it means that it's a subset of the WAN in the city size. Or there's another type of network called the PAN, personal area network. So this kind of network is used in some very special cases. So we won't go to details in this type. Then it's network architecture. There are 2 main types of the network architecture. First is called the client and server mode. The other is called peer-to-peer mode. We call it the P2P mode. So in the first mode, in the network, there will be 1 or more servers. So servers act as a manager of the network. So all the other computers act as the clients. So if the clients want to do something, it has to go through the server, such as sharing the information or go to the network. So everything should go to server. So this work, we can also give that name. It's called a centralized network. And the second is P2P network, different from the client and server mode. In a P2P network, there's no server. Act as a central, like a manager to managing the whole network behavior. So that's the good thing. So each computer does not need to get approval to do something in the network. But the drawback is that since there's no central manager, so the network resources, the network behavior has to be managed by different computers itself through the negotiation and finally come up with some consensus. So this may be a little efficient, but you can get a much faster network performance sometimes. So that's two main types of the network architecture. So the next important concept in computer networks is called network topology. So network topology means how computers are connected with each other. So the first, the simplest network topology is called the star topology. So in star topology, one or more smaller computers are connected to a central host. So nodes can communicate only via the center computer. So if the host goes down, so the network becomes inoperable. So it's widely used in office and home. So what does this star topology remind you? So in the server and the client mode, right? So it is a star topology. So server will be center of the network, and all the other clients will directly connect to the server. So that is the star topology. The next topology is called the ring topology. So in this topology, computers attached with each other in a closed cable, just like this, in a closed cable. And each node has exactly two neighbors, just like in the ring, and no central devices for controlling the network. And any break in the connection and the entire network fails. So if one computer died in this ring, then this ring will be broken and the network will stop working. And previously it's used in the LAN network. So ring topology was used before because it doesn't require so many connections and there's no center network. So it was very popular before because it's a simple topology, but it has many drawbacks as we mentioned. So the third topology is called bus topology. So in this topology, all nodes or computers are connected to a single line via an interface box, just like this figure. So we have different computers and they just connected to this single line. We call it bus. So if one of the nodes or one of computers fails, so the whole network is not affected. So that's the good thing about this topology. So nodes can communicate with each other without passing the server. So there might be a server in the network, but actually this server has no response to control the whole network. Maybe just act as a like share center or something. So nodes don't need to pass the server. But this topology has one big drawback is that it's not appropriate for the network with heavy traffic because all the traffic has to go through this single line, which acts as a main street. So if we have too many traffic in this main street, we'll have the traffic jam, which means in the network, we call it the network congestion. So actually in many high-speed network, bus topology is not appropriate. And the second big problem is the security problem. So the security of the bus network is very low because all computers will receive the signals from the source. So in this, for example, in this network, if we call this computer A and it's B, so if A wants to send something to the B, but actually computer C and D will also receive the information from A. not only B. So that's the another major problem. But still, bus topology still used in some special cases, especially in the factory where the network is isolated from the outside. So where security is not the big issue. So this topology is still used in some very special scenario. So the last topology is called mesh topology. In this topology, each computer is interconnected with each other. So it's just like in this figure, we have 5 computers. So all computers has directly connection to another one. So which allows send data from different different devices simultaneously. So you don't have to go through another computer to help you. You can just directly talk to your destination. So the good thing about mesh topology is it has high redundancy, or we'll call it high reliability. So even 1 or 2 computer dies, there's no effect to the network. You can still talk to your destination without any problem. But a major problem of this topology is it's very costly. Think about that. You have to connect all the computers with the cable. So if we have like hundreds of computers, so the connection will be massive. So which is not good for very large size of the network. So that's our last network topology. And the next is network standards and protocols. So what do standards and protocol mean? Standards and protocols define a set of rules for data communication and network. Protocols are a set of rules for message formats and the procedures that allows machines and application programs to exchange information. These rules must be followed by each machine involved in the communication in order for the receiving host to be able to understand the message. So protocols and standards, just like our language, if two of you want to understand each other, so firstly, like both of you should understand the same common language. Otherwise, you never understand each other. So same as the standards and protocols. So for a protocol, it should has the following functions, such as the size of the data package, and it should provide a numbering scheme of a data package, provides error and flow control, define mechanism of connection, establishment and termination, manage data security, manage data routing algorithms for delivering data, and also log information. So these rules just some fundamental functions provided in the protocol. So in many protocols, they may contain much more functions. So all these functions has to be agreed by different computers in order to understand each other. So to better understand the protocols and standards, you need to understand this module called OSI module very clearly, very thoroughly. So this OSI module is the most important and most fundamental things if you want to learn the computer networks. So you need to bear that in mind because it gives a way of thinking that we should use different layers to explain our protocols. And why a layered protocol, network module is important, because firstly, it can reduce the complexity since we define different layers, and on different layers, it has different functionalities. So this will make our standards very clear and well structured. Second, it has a standardized interfaces, because if two protocols want to talk to each other, then you should find which layers it belongs to, and then you should find the corresponding interfaces to communicate. It also facilitates the modular engineering, especially when if we want to develop a protocol. And also it accelerates the evolution. So if you want to improve the protocols, then you should understand in which layer you get a problem, then you can work on this layer and help to improve your protocol, not like improve the whole protocol stack. And last is it can simplify the teaching and learning. So in this case, you can learn like layers by layers, and it will be much easier for you to understand the protocol. Now let's talk the first layer, which is on the bottom, called the physical layer. So physical layer describes all the physical media. So physical is all about hardware. So like everything about the electronical signals, hardware goes to the physical layer. To activate, maintain, and deactivate the physical connections is through this physical layer. And to convey the digital bits into electrical signals, it happens on this layer. It also helps to synchronization of the bits for the synchronous transmission mode. If you remember what we just learned, for example, all the hardware like cables, fibers, wireless connections, hubs, they are on this layer. So the second layer is called the data link layer. Some people call it the mic layer, but it's not that accurate. So data link layer is more formal names for the second layer. So on this layer, it transfers a raw transmission facility to a reliable link. So the first important function on this layer is to do the framing. It means that we should divide the string of bits received from the physical layer into manageable data units called frames. And the second important thing is the physical addressing. So we should add the header to the frame to define the physical address of the sender or the receiver of the frame. So without a physical address, we don't know where to send our package, or for the receiver, it doesn't know. So who sent this package to him? So that's the important thing about the physical address. And next important function is called access control. It determines which device has the control over the link at any given time. Since our computers are connected with each other, it means that all these computers shared transmission media has the right to send and receive data anytime. But the problem is that if we don't have any rules to define that which computer has the right to send and receive it at a given time, and then it has higher possibility that different computers will send their data at the same time simultaneously. Then it will cause very serious network congestion problem. So in order to avoid this problem, then we should define the rules to control the traffic. Then it means that we have to use these access control techniques. And next is error control. Error control is also important on this layer, as we learned that we have different cables for network, and some cables are prone to noise. It means that packet or frame can be corrupted. And how to detect or even how to correct the error of the frame is very important. So then at least we should detect errors, because the erroneous package will ruin our network. So error control is very important for our network. So the data link layer network, there are many examples. For example, the Ethernet, that's the layer 2 network. Also for the PPP and the switch, they're all layer 2 networks. So the layer 3 is called the network layer. So network layer is one of the most important layers for our computer networks. It is responsible for deliver the individual package from the source host to the destination host. So this address is different from the previous MAC address. So for the MAC address, so packages just transmitted within the LAN in a small network. But if we want to deliver package from the larger network from different LANs, across the different LANs, then we should use the network layers, which is the IP address. Secondly, this layer provides connectivity and path selections between two host systems. Because from the source nodes to the destination nodes, it may exist many different paths. So how to select the best path or the shortest path is one of the most important things in the network layer. Then the network layer determines the quality of service by deciding the priority of the message. So the quality of service, we also call the QoS, is also very important for our networks because different message, different service may have a different priority of different requirement of the networks. For example, our email system. For the email message, it doesn't have a very high requirement of time. So it's not time sensitive because if you send a message or send the email to the receiver, if even after like 10 minutes, the receiver will receive the email. So it won't have a big impact. So the receiver won't complain about the 10 minutes to get the email, but the reliability of the message is important. So if you want to send something, the receiver should receive exactly the same as you want to send. But this will be very different from the live video streaming. The live video streaming will be very sensitive to the delay. Otherwise, you'll see your video is very laggy. So it will be seriously interfere your user experience. But for the live streaming, you don't need, you don't care about the quality of the video very much. It means that our video message can be corrupted, like to some extent. So our quality of the video may be affected, but you don't really care about that. Once you can see the picture, that's fine. So it depends on the like the service, depends on the different types of message. We can give the different quality of service to this. So that's the job of the network layer. So next, this layer should also able to break the larger package into smaller package, because like in some cases our message could be very large, especially for our IP network. So one package can go to several megabytes. So which is too big for some routers, because if you want to send your message to a destination, this message may go through like several routers, but different routers have different ability to handle the package. And some router cannot handle too large package. So then before to go to send your data, you should divide your large packet into some small pieces. And then at the receiver side, the receiver should have ability to assemble these small pieces again to form the big package. So this which we call the fragmentation in the IP network, and it's also an important function for the network layer. So the most famous network layer protocol is the IP protocol, and also an ICMP protocol is also the layer 3 protocol. So ICMP protocol is there's another name called PNG. So probably you have used that before to ping some website to see if this website alive or not. So layer 4 is called the transport layer. So this layer ensures the data transport reliability. As we mentioned that reliability is very important for many services. So how to do that? So this layer has many mechanisms to improve reliability, such as handshakes or some techniques to like acknowledgement to ensure the reliability. Another important thing on this layer is called the flow control. And the flow control is important. It is because different computers of the network may have the different data processing ability. So if the sender sends something to the receiver, like continuously send to the receiver, if sender send the message too fast and the receiver receive too slow, So you can imagine that after period, so sender sent like too many things to the network, but the receiver cannot process it. So this message will be congested in the network, which will cause the network congestion. So how to control the flow and how to let the sender send it a little slower and then let the receiver to have time to digest all the message is important. And it's the important function for the transport layer. So for the transport layer, the most famous protocol is the TCP protocol, which is designed to guarantee the reliability. And the other important transport layer protocol is called UDP. So UDP is very different from TCP. So UDP is more for time and sensitive services. So UDP, it doesn't guarantee the reliability, but it does guarantee the latency. So try the best to shorten the latency. So that's very different, the two protocols on this layer. Then is the layer 5 and layer 6, which are a session layer and a presentation layer. So this layer, they are just the reference layer. So in reality, we don't have any corresponding protocols to these two layers. That's why we just ignore these two layers. And then let's go to the last layer, which is the application layer. So the application layer is responsible for providing services to the user, and it interacts with software applications that implements communication components. So most of users, they don't care about the lower layers, such as physical layer, the data link layer, network layer. They don't care about how packets find the way from source to the destination. How do we do the flow control to control the traffic to avoid the network congestion? So users don't care. What they care is only about their service. It's about their applications, such as emails or video streaming or FTP server or a web browser. So all these applications are supported by the application layer and API interfaces, such as this protocol, HTTP, is for our web browsing, or HTTPS is for online banking or online payments. FTP is for file transfer between different servers, different computers, or SMTP is for email systems. So that's our last layer. And now let's look at some well-known or famous protocols in our computer networks. First is the Ethernet. So Ethernet has been widely used in our daily life. So I don't have to mention that. So Ethernet specifies no central computer or device on the network nodes should control when data can be transmitted. The Institute of Electrical and Electronics Engineering, we call it IEEE, this organization, defines the Ethernet in a number of IEEE 802.3 standards. So from now on, every time you saw this IEEE 802.3, it means that this represents the Ethernet standards. So these standards define the physical and data link layer specification for Ethernet. It means that for the Ethernet standards or protocols, it only contains the physical layer and data link layer. So there's no layer 3, layer 4. So that's a very important you should bear in mind. And the fast Ethernet physical layers can carry traffic at the nominal rate of 100 megabits per second. Okay, it's bits, not bytes, small bit. So 100 base TTEX is by far the most commonly used. So even right now we have a much higher Ethernet protocols, but this 100 based TX is still the most commonly used protocols. So nowadays, this gigabit Ethernet is the various technologies for transmitting Ethernet frames at the rate of gigabit per second. So nowadays, this one become more and more popular, but especially for the essential places, such as for the banking system or for the enterprise. But for the home usage, this is still not that popular. And token rings is our next standard. So token rings specify that computers and devices on the network share or pass a special signal we call token. So in this network, so if you want to send something, first you need to get a token or signal to do something. Otherwise, you have to wait until you get the token. So this token rings protocol is used to be applied in the LAN, but not popular due to the Ethernet. So this protocol has been stopped using right now because it is very inconvenient, because every time you have to wait for your token to do something, which is very efficient if our network size is very big. Then it's the famous protocol, TCP/IP protocol. So actually, these protocols are a set of protocols. It's not only about TCP protocol and IP protocol. It's a huge bunch of protocols. So TCP/IP protocol defines how messages are routed from one end of a network to another. And this is an example package from this TCP/IP protocol. So here you can see we have 7 layers of the OSI module, but in reality we only use like 5 layers. So for these 2 layers, we'll combine with the application layer. So in the first 2 layers, it has normal network access, just like the Ethernet. It's based on these 2 layers. Then we have the network layers. Then we have the IP protocols. Then we have the ICMP protocol for the ping message. We have the ARP protocols to translate the MAC address to the IP address. Then on the 4th layer, transport layer, we have our TCP protocol and the UDP protocol. And on these higher layers, we have different protocols for different applications. So TCP for the web browsing, SMP for the network management, FTP for the file transfer, and TFTP, same thing as FTP. So SMTP for the email telnet, also for the information exchange, something like that. So that's the one example of the TCP/IP message. So how communication standards might work together? And here I just one simple example. The first step is that you need to have your communication software. So for example, you should use the browser to send a request of the web page on the web server to be displayed on your computer screen. Then your computer should use this TCP/IP protocols or standards to establish the connection with this web server that stores the request web page. Since this web page may be very large, contains the text, the pictures, even some audio, video. So this web page may be divided into different packages. And for each package, we should give the source address and the destination address. So in order to let this different package to arrive to your own computer, okay? And then after all this message or this package arrive to your computer, then you should reassemble all this package to reform the normal web page. So the router along the way should send this message over the internet from the web server to your computer. Okay, the first part is from the higher layers, from layer 3. But what happened on low layers, on layer 1 and layer 2? So in this case, since we are using Ethernet, so that's the job of the Ethernet protocol. So the Ethernet standard of protocols controls how devices like our adapter cards and routers and modems share access to the medium, like cables and lines, and how devices transmit data over the transmission medium. So that is what happens on the lower layers. So here is just example of this from the different layer point of view to tell you how messages are transmitted. So on the layer 2 and layer 1, we have our Ethernet. Here we have the MAC address header. So this header tells you what's the physical address of your computer, which is different from the IP address. So what's your MAC address? It is. And then this is an IP layer. So in IP layer, we have our IP header. So most importantly is the IP address. So it will tell you where your computer is located in the network. And then it's the TCP layer. So on this layer, we have our TCP header. So since you are sending requests to browse the web page, so the reliability is the most important thing. So TCP protocol will guarantee that how can you reliably receive your web page from the web server. And last is our user data, which is embedded into TCP payloads. So that is the whole package from this example. So next is Wi-Fi standards. You may use Wi-Fi like every day, but you may don't understand what does Wi-Fi mean. Wi-Fi is simply a trademarked phrase that means IEEE 802.11x. So X represent different letters. It can be A, B, or G. So it specifies how wireless devices communicate over the air with each other. So now our Wi-Fi standards has a different generations. So first is our Wi-Fi 1, so with .11a. But actually this standards is never come to the market. It's just very initial standards. So the real Wi-Fi comes from this one, Wi-Fi 2.11b, which is released in 1999 from last century. At that time, the maximum data rate is kind of slow, only 11 megabits per second. Then later we have the famous .11g, released in 2003. So the data rate increased to 54 megabits per second. Later, like about 10 years ago, we have the fourth generation, .11n. So from this generation, we can support another frequency, not only the 2.4 gigahertz, we can support 5 gigahertz. And on this generation, the data rates increased to 600 megabits per second. So this .11 AC was released like six years ago. It's also a very famous one. So at that time, the data rate increased to 1.3 gigabits per second. And from last year, the latest Wi-Fi standard released, so which is called the .11ax. And for this, so in this generation, the maximum data rate increased to 10 to 12 gigabits per second. But nowadays, this Wi-Fi 6 hardware is not that often seen in the market. So like most of the time, you can still buy the Wi-Fi 5, which is .11 AC, but 11ax, the hardware is very, I would say, not often seen in the market, very rare. So next famous protocol is Bluetooth. And also you may use it for a long time. Actually, for the Bluetooth, for the first generation, it was managed by this organization, IEEE standards. And first is named as IEEE 802.15.1. But that was a very big beginning. But IEEE stopped maintain this Bluetooth long time ago. So nowadays, Bluetooth is not an IEEE standard anymore. So Bluetooth defines how two Bluetooth devices use short-range radio waves to transmit data. So which is very different from Wi-Fi. So Bluetooth is more for peer-to-peer or point-to-point communication. It's not for a different bunch of devices like computers connected with network. So Bluetooth is different. So that's why you can see like the Bluetooth, the headsets, Bluetooth keyboard, mouse, but you never see a Wi-Fi like headset, right? Wi-Fi keyboards. So because that's the different usage. So the frequency for the Bluetooth is also same as the Wi-Fi, 2.4 giga to 2.485 giga. So you may think that since the Bluetooth use same frequency band with Wi-Fi, so do they interfere with each other? So the answer is yes. So if, for example, if you have UV at home, you use Wi-Fi to download some high speed like video, then at the same time you try to use your Bluetooth keyboard and Bluetooth mouse, you feel that sometimes you lose control of your keyboard and mouse. It is because this Bluetooth and Wi-Fi, they do interfere with each other. So for the Bluetooth, it also has a different generations. So the first generation we call Bluetooth 1. It starts from last century, 1999. So at the beginning, the data rate was very, very slow, only 1 megabit per second. And for the Bluetooth 2.0, the data rates increased to 2 and 3 megabits per second, but still quite slow. And even for 3, so the speed is still slower than Wi-Fi. Then from the Bluetooth 4, since becomes a little different because from this version, Bluetooth focus on the low energy market because many devices, they are focused on the energy consumption, low energy consumption. So that's why you will see you have the Bluetooth headset, but no Wi-Fi headset. You know why? Because your headset is powered by battery, and usually Wi-Fi consumes a lot of power. If you use Wi-Fi headset, probably you can use it for 1 day, and your headphone will out of battery. But Bluetooth has spent some energy to improve their like energy consumption. So that's why in many cases we can use the Bluetooth to some like electronic devices for the low energy consumption. Then for the Bluetooth 4.1, start to support the LTE, which is from the telecom network, and then from the Bluetooth 2.4, security become another important feature for the Bluetooth. And lately we have the Bluetooth 5.0. So that is as far as I know, that is the latest version. But since the new Bluetooth standard is still under development, so Bluetooth 5 is nowadays still the newest one. So in this Bluetooth, it introduced some new features, such as a double and 4 times in terms of coverage, range, and speeds when compared with the previous Bluetooth 4.2. So that is about the Bluetooth standard and protocols. So the next protocol is RFID, which is radio frequency identification. So if we remember, we mentioned RFID protocols in the very beginning of our lecture, like the first lecture in this semester. So RFID defines how a network uses radio signals to communicate with the tag placed in or attached to an object or animal or a person. And the RFID uses a radio wave to transmit data, and it has two types. First, called passive RFID, that's called active RFID. So for the passive RFID, it's just like this. It doesn't have any batteries at all. So it only uses the signals from the sender. So it will absorb the signals from sender to trigger the chips inside and send back some signals back to the sender. Then we have our active RFID. So for the active RFID, it contains a little tiny battery in the RFID tag. So the good thing about active RFID is that it can provide a little longer communication range and also some security figure. So this table gives you some idea about different types of RFID. So you'll notice the RFID can work in different frequency bands. So lowest, which is around 100 kHz, which is super low. And this kind of RFID is not that popular because if the frequency is too low, then the RFID will become, the area will become much larger. So that's due to the physical reason. And for the highest frequency band, it can support up to like 5.8 gigahertz. So that is range of the microwave. So in this case, RFID can support very high data rates. But problem is that this RFID will be very costly and can only be used as an active RFID, so it requires battery. So that's why it's very expensive. But the most popular RFID is working with this area, this frequency band. Why it's like that? You can see the price. So the price will tell you which RFID is the most popular one. So in this RFID, so the good thing is that it's the passive RFID, so it doesn't require the battery, and also it can provide kind of a moderate, good data rates, and also the range can goes from 1 meters to 12 meters. But for the 12 meters, it definitely need the active RFID because for the passive tags, it never goes to 12 meters. So that is something about the RFID protocol. So the next protocol is the NFC protocol. NFC means near field communication. So actually, NFC protocol is very similar to RFID. Why? Because NFC is a specialized subset within the family of the RFID technology. So that's why many students will get confused about NFC and RFID. And NFC is designed to be a secure form of the data exchange. So compared with the normal RFID protocol, NFC can encrypt and decrypt the message, so to provide the secure communication between the sender and receiver. So that's one of the major difference between the normal RFID. And also an NFC device is capable of being both an NFC reader and NFC tag. So what does it mean? It means that for NFC standards, the communication is two-way communication, which is different from the traditional RFID. And also, some NFC devices are able to read the passive high-frequency RFID tags, which are compliant to these standards. So we can use these NFC-enabled credit cards to read some RFID tag, so which is not possible for the normal RFID technology. So the last protocol or standards I want to mention here today is the 1G to 5G, which is from our mobile networks. So the 1G, which is first G, is voice only. It only uses the analog technology to transfer data. It means that the data rate is very slow. It only has 2.4 kbps, which is super slow. But that's not the only problem. The biggest problem about 1G is that there's no security at all. So there's no encryption of your information. So if two people talk through the 1G networks, you can listen very clearly about what they're talking through their phone. Then from the 2G, which we call the GSM, and call and text, now they're like encrypted. So in this way, you cannot like hijack the information. And then some data services are provided, such as like the short messages or in-house short message, we call the EMS, or we can send the pictures through the message, or we can provide this like multimedia message as well. And the 3G, we can support more data, so we can use the video calling through 3G. Then we can use our mobile internet to serve the network through your mobile phone. And the data rate now increased to 2 megabits per second, which is a big change from the first G, right? But when you're moving, so the data rate will decrease to 384 kbps. So next is 4G, also called LTE. It's the current standard we are using right now. It can support the HD mobile TV. So now we can use our mobile phone to watch the HD video from YouTube. It can also support video conference. So we can use our mobile phone to use Zoom to join the remote conference. So the speed will now is increased to 1 gigabits per second, even for slow mobility communications. So, but there are many other important figures in 4G, but I won't talk about here. Now it's the 5G. 5G it says coming soon, but actually it's already here. In Bendigo, we have many 5G base station already. So it promises a significantly faster data rates, higher connection density, much lower latency, and energy savings, and among other improvements. So 5G, I would say 5G is not designed just for our humans, because for our normal user, 4G is already good enough. It can support most of the applications we want, but 5G is more designed for machine-to-machine communication. So that's why when we talk 5G, we always talk about networks, the IoT, the Internet of Things. So 5G will connect like most machines together to form another new networks. So that is a very attractive thing about 5G. So the last topic today is the internet. So before we introduce internet, I want to think for a while that in your opinion, what is the internet? Maybe you are using internet every day, but you never really think about this question, right? So as we mentioned previously in this lecture, you can consider the internet is the biggest WAN, the biggest wide area network. So it connects millions of businesses, government agencies, educational institutions, and individuals. And compare with our world like in the last century, the internet has completely changed our lives and our society. So nowadays you don't watch TV, right? Because you can watch it from your laptop, from your desktop, even from your smartphone. And you don't need to go to the shopping mall or shopping center to buy things, because you can buy almost everything online these days, and even with the much lower price. And you don't need to come to the university to attend this lecture, because I've recorded for you, and upload to our system. Then you can watch it online anytime, anywhere. So I can keep on listing these examples. So how was the internet invented? So in the very beginning, there's nothing called internet. So the first version of the internet it has another name called the ARPANET. It originates in September 1969. At that time, only about 4 computers are connected in this network. And this network is at that time super slow, and it's only for military use. After like 5 years, 6 years, when it's come to 1975, at that time, there were already about like less than 20 computers connected in this network. And people and researchers found that it's very convenient to use this network to share information across the whole United States. And so even until the 1989, the ARPANET still used for the military use. So after 1989, then the ARPANET comes to the normal use for the normal computer. So most importantly, you should know that our lives will keep on changing due to the internet, because our internet technology is always evolving. Even nowadays, there are still many new concepts like appear every day. Maybe you have heard some new concept called tactile internet. It means this internet is super fast and has a super low latency. And also some other buzzword called SDN, a software-defined network. So it will be widely used in the future. So we can use software to virtualize our hardware, which will make our network much more efficient and low cost. So in order to understand what will happen to the internet, first you need to understand some fundamental knowledge about internet at this stage. So where can you get your internet service? Firstly, you need to find your ISP, means Internet Service Provider. So the ISP will provide you the internet connection with the sufficient bandwidth and some other internet services. But most importantly, they need to assign your computer with the IP addresses when you connect your machine to their network. So what is IP address? Probably have heard that before. So IP address uniquely identifies the location of each device connected to the internet or any other network. And this is one example of the IPv4 address, and it is IPv6 address. So these two addresses looks quite different, and because IPv6 can support much larger number of addresses than IPv6. So that's the main purpose for IPv6. But there will be many other differences, and this is out of scope of this lecture. So you will learn this from other subjects from the program. So the next concept is called domain name. Domain name is a text-based name that corresponds to the IP address of a server or of a computer. Actually, any computer can have its domain name. And the reason we use domain name is because this IP address is very hard to remember because it consists of like meaningless numbers. And if we want to visit a server or website, theoretically, we should use the IP address to visit them. But it's very hard to memorize all these like meaningless numbers, just like your phone numbers. So it will be hard for you to memorize all your friends or your relatives' phone number, right? You have to refer to your like phone book. So like domain name is kind of like a phone book of the IP address. For example, Google. So Google is the domain name. Actually, when you type the google.com in your browser, so there are some many other things, operations behind it to find the corresponding IP address. And then you choose IP address to go to the google.com. So I will show you one example. So if we want to visit google.com, we just need to type in the Google's address, right? Then we can visit the Google website. How can we use the IP address to directly visit google.com? Then we should find the address of the google.com server, right? So we can use ping. Now we know what is the corresponding address for the Google. So just copy the address, and then we go back to, and then we copy to here, and we just paste the address. Then we can still visit the website. So now you know that the domain name just kind of like a nickname of an IP address. So instead of remember these meaningless numbers, we can use much convenient domain name to visit the server or website. So then you may wonder, how can we translate a domain name to the corresponding IP address? Actually, there's a specific server to do the job called the DNS server. So DNS server is configured by your ISP when you connect to your network. So every time your computer connects to the network, your service provider will directly give you the IP address of the DNS server. So every time you go to some websites, this server will help you for the translation. So let's see how a browser displays a request web page by using DNS server. So first step, you run your web browser and enter the web address in the browser's address bar. So for example, the google.com. And then the web browser will communicate with the DNS server maintained by your ISP or any other providers. So the address of this DNS server has been given to you when your computer connected to the network. And when the DNS server received your request, such as at google.com, it will look up its database and find the corresponding IP address, and then send the address to your computer or your mobile phone. And then once your browser get this IP address, you will connect the web server on this specific IP address that requests the content of the desired web page. And the web server fulfilling the user's request will send the desired content to your web browser, which is formats the page for display on the screen. So that's the whole process of how to use a web browser to enter the domain name, and finally you get your desired web page. So when we use the internet, we cannot avoid these concepts, the World Wide Web. So what is the World Wide Web? It's short for www, commonly known as the web or web page. It is the collection of related web pages and associated items identified by uniform resource locators, short for URL. We also call it the web address. Then we have our web servers. So the web servers deliver the request web pages to your computer or mobile devices. And the web page is usually transferred via this protocol called the Hypertext Transfer Protocol, short for HTTP. It is the abstraction code protocol that we have mentioned in this lecture. And how a web page is designed. So most of the web page is designed by using this language called the hypertext markup language, short for HTML. So we're going to learn this HTML language in our next lecture next week. And we also have browser, which we have mentioned before. So web browser is the application software for navigating and viewing a web page. And different web browsers has different performance or different way to display the web page. So when you surf the internet, you have to use this web page address to visit different servers to see different web pages. And actually, this web page address is not meaningless. It's kind of a very structured address, just like in our normal address. We have the state, country, state, address, and the street number. Same for the web page address. So now let's look at this web page address as an example. So this in the beginning of this address, if we have our protocol, it means that this web page is delivered by HTTP protocol, and www is the host name, followed by the domain name, which is we mentioned before, and then it's the path. So this web page is located in this folder from server called history, and finally it's the web page name. So this web page is saved in the server as this name. So every time you enter this web page address into a browser, so browser will send to the DNS server to find the corresponding IP address to this domain, and then we go to the server to tell, okay, what web page you want to visit. So server will know, okay, in which path they can find your request web page and what's the name of this web page. Finally, you can see this picture or web page from your monitor. So the website technology is also evolving. In the very beginning, we called the web 1.0. At that time, it is just like the content for user. It means at that time, our designer, the web programmer, provide the information to the user. So the user just passively receive or accept the content online, such as a search engine, educational website, news website, media, entertainment, government, business, or even for the e-commerce, business to customer, customer to customer, or business to business. So at that time, user just passively accept the information. Then comes to Web 2.0. So now it's changed to the content by user, because later we have our social media, social network, such as Facebook, Wikipedia, blog, and Twitter, media sharing. This kind of websites start to become very popular. So from now on, the content is more provided by user itself, not provided by the website. Now there's a new trend called the Web 3.0. The Web 3.0 is kind of a new concept. It's not widely accepted by the old people, but it's happening. So for the Web 3.0, there are many new features such as AI, artificial intelligence. So the AI will not only generate information to us, because there are too many informations by human beings. We cannot process too many information, so we have to use AI to help us to write articles, to post news, to make videos. So AI will do that, and also the user can use AI for them to find the best information they want. And the other is called 3D graphs. So previously, the web page is most times 2D, and later we can display 3D in our web browser. So that's a feature, and there's a more other features. So you can search for by yourself if you feel interested. So then is the internet services. As I mentioned, when you find your ISP, internet service provider, they may provide you some basic internet services, or there are many other internet services already online, such as email and internet messaging, chat rooms, discussion forum, and the voice over IP. We call the VoIP, such as Skype or FTP, file transfer protocols. So there are many existing internet services. So I won't go through these services one by one. So you can just look at it by yourself and to see which one you use the most over the time. So that's all for today's lecture. If you have any questions, please send me an email. We can set up time to discuss. Thank you. Thank you so much for today.